Strong magnetic fields found inside stars, presented by Science at NASA. Some scientists ply their trade at lab benches, working with test tubes and Bunsen burners. Others spend time in the backcountry, analyzing rocks and landforms. But some astronomers use stars as their laboratory. Dennis Stello of the University of Sydney School of Physics in Australia says, if we want to understand how stars form and grow old, we need to understand all the physical ingredients that govern their evolution. Current standard models of stars ignore magnetic fields, mainly because they are one of those aspects that are hard to model. As it turns out, that could be an important omission. Based on research conducted by Stello and an international team of colleagues using NASA's Kepler spacecraft, Stello says that magnetic fields are very common and hence should not be ignored. Kepler is famous for finding planets, but researchers using the space-based observatory also learn a lot about stars. Kepler routinely surveys thousands of stars, looking for slight variations in brightness that signal the transit of a planet across the stellar surface. For each star in the survey, Kepler collects a long-term record of the star's brightness, a record that can be used for astroseismology. Astroseismology is akin to the science of seismology. Earthquakes send waves rippling through the body of Earth. By analyzing those waves, seismologists can figure out the interior structure of our planet. There are also waves rippling through the interior of stars, acoustic waves. Stars are rumbling, noisy spheres of hot gas. Sound waves bounce around the interior and cause the stellar surface to vibrate, much like the head of a drum. These vibrations reveal themselves as fluctuations in a star's brightness. Astroseismologists analyze brightness fluctuations to study the interior structure of stars, including the strength and distribution of magnetic fields deep below the stellar surface. This is exactly what Stello and colleagues did using Kepler observations of 3,600 red giant stars. Stello says, about 60% of the sample showed evidence of strong internal magnetic fields, and about 20% have strong magnetic fields all the way down in the core. Theorists had conjectured that magnetic fields might exist deep within stars, where they would have a major effect on stellar evolution. The Kepler data showed that this is indeed the case, especially among stars more massive than our Sun. Stello notes that because most action in a star is in the core, the state of the core is very important for how the star evolves. Having strong fields in its core could potentially have significant effects on how the core spins up the outer layers of a star. What's next for Stello and colleagues? Back to the laboratory, he says. That is, back to the stars. For more news from Kepler and other NASA observatories, stay tuned to science.nasa.gov.